Well, we'll do problem number 8 for last time's quiz. I asked you not to do the whole thing, but just to look at the question about the claim that says the mean salary is equal to 46,000. So we always write down word claim, and once we produce the claim about mean, which is equal to 46,000, then I will be also, well, I guess deciding if it's equal or not equal, right? And first step is to, of course, notice this belongs to H index 0 because of equal sign. So the opposite of equal will be not equal. So that will be my H1, the alternative hypothesis to one we have here. And then we'll make a picture of this by using the fact that we have two-sided hypothesis, because if mean is not equal, it means it could be either less than that 46,000, I can put 46K, or greater. So not equal means it's either less than or it is greater than 46,000. And that's what you had to say here for the quiz. It's a two-sided hypothesis, and that's all we needed. But of course, I'm gonna go ahead and solve this problem by making two-sided picture of the H1, that so-called alternative hypothesis, H index 1. In some books, they say H index A for alternative, but H0, H1, I guess, is kind of standard. So now I need to have the border values, the critical values for the Z scores that corresponds to the level of significance of 5%, 0.05, that must be split into two equal pieces, right? Because picture is symmetric, normal distribution, always symmetric with respect to the center. So if I divide the significance of 5% into two equal pieces, I get 2.5%. And from there, we will get the Z scores. All I need is just to type Triola formulas or Triola tables, click on the first choice, and go to the middle of these tables where we have those Z scores that I'm looking for right now. So I'm looking for 0.025 here, and in a table among the areas, I can see exactly that number 0.025. You still remember how we use tables? You start on the top and notice the numbers start to increase. 16, 22, 30, and so forth, and I need 250. So eventually we get 200 and then 250. So we see what row and the column this number is gonna correspond to. And once I saw the row and the column here, then I set together -1.9 with 6 of those hundreds, and same thing I do on the other side because the picture is symmetric. And this is where I'm going to have the comparison number for the data that we're about to calculate using the favorite z-score formula, right? That's x minus mean divided by standard deviation over square root of n if that's a sample size, and that's sample mean then, because we have here a sample of size 65. So now I'm going to take all these numbers given in the exercise, such as a sample mean of 45,678, and then finally a standard deviation, which is given as a 9,900. So we plug those numbers in a formula and get the z-score that comes out of this sample. So let's get those. So what is population mean, mu, that I have to subtract from this 45,678? Remember? It's always here in the hypothesis. So we subtract here 46,000, and then we divide by 9,900 standard deviation that is placed over square root of sample size was 65. So all numbers are nicely given to us, and I will be using the parentheses when I enter this in the calculator, in my favorite scientific calculator that I also have here. So put scientific calculator, and choice one uses the Desmos. So let us plug the numbers in. So do this. We're going to have a final exam next week, and you will be asked to do a problem similar to this kind of exercise. So you're going to definitely need to find the z-score. So week after next, actually, we have a final on Monday, and then next week I'll spend reviewing what you need for that final. But the good thing is that I found the z-score. It is negative 0.262 ... So now the key part of the exercise is coming. I must make a decision what region we're in. Remember, H0 is always the one in the middle, the big one, and H1 is the one on the outside that we made a picture of. And this number is someplace around 0 on the left side of it, right? So it's definitely less than 196. So it is here. So it is in H index 0. So I say yes to it and no to the opposite. And what I just did, I just accepted my claim. So whatever they claimed about, looks like the salaries, starting salary for college graduate of $46,000 is correct. And we were able to verify it by considering 65 element sample. How about that? So it's very interesting procedure, and looks like the problems here in the section are actually all pretty much of the same type. They give you the claim, and then you need to decide if it's one-sided or two-sided, and then go ahead and get yourself a z-score. So the same exact story is in the previous section, which is talking about the proportion. Remember, sometimes we can use mean when we are talking about the averages, but sometimes talking about the averages making absolutely no sense. And then we are talking about proportions. So what percent of people is doing something or whatever. And turns out the difference will be in the formula for the z-scores. So they have here x minus mean. Remember, for binomial, it's np, and then the square root from npq, which is not very surprising here, right? And that's what they actually have in a case if they are dealing with the binomial distribution. But if you have the formulas given, if you actually have not a mean but a proportion given, then the formula is going to be a little bit different, because what you're going to do is basically divide everything by n. And look at what's going to happen if you divide each term here by n. Definitely np will be just a p, then x over n will be the proportion of that sample. And then if I divide by n, my denominator, then n will be inside the square root on the bottom, just like that. So it's a little algebra that given us the formula, which is pretty much the same as to what we used to have for binomial distribution whenever we deal with P and Q. So let us do the problem and see that it's really going through exactly the same process, but utilizes proportion rather than the average. So I'll try exercise number 3 here that talks about the survey that has 2,500 brides. Well, so it looks like that's a sample size, right? 2,500 that ended up with 60% of them spent less than $750 for the wedding dress, wedding gown. So we have the 60%, and I call it as P, right? Percent, P, 0.6. We never use percentages, hundreds, 60 hundreds or 0.6. Since it's from the sample, I use that bar, but we use hat instead of bar for some reason. And then they also say the significance level that we call was alpha is 1%. At this significance level, I want to test the claim, the key part that says less than 62% of the brides. So they are claiming that less than 62%, so P is less than 0.62. So whether they claim something correctly or not, we don't really care. We're just doing the problem here. So we start with producing hypothesis. And since we don't have equal sign here, remember where it goes? H index 1, right? So its friend H0 that must have equal sign will be its opposite, will be P is greater than or equal to 0.62, just like that. And this is a great start. And we have one-sided hypothesis, right? Because my H1 here is smaller, it is on the left side, and this area is 0.01. That's my alpha, that's my significance level, 0.01. So H1 is always a little tail, so H0, its complement is always bigger area. And then we need to get a critical value, the cutoff in between of H1 and H0, that right away will come out from that favorite tables, right? So I just need to get the number 0.01 or the closest. So if I start on the top and keep going down, I notice that 0.01 is in between of those two numbers, 102 and 99. It's like 100 in between 99 and 102, and 0.0099 looks like it's closer, right? By 1 unit, because the other 102 is 2 units away. And this gives us the idea of the border value then. That's 2.3 that I attached 3 from the top, that 300s from the top, and there we have the value. So we need to get a z-score calculated. We need to put in the formula P and its friend Q. Remember Q, the complement of P? Q is 1 minus P. And P is 1 minus Q. They're complements of each other, the opposites. So if I know what P is, it's 60%, the complement is 40%, 60-40. So they always add to total of 1. So if you want to subtract 0.6 from 1, you get that 0.4, as usual. So let us plug the numbers in the calculator. So the formula is up here. So I'm going to be using 0.6 for my P with a hat. 0.62, right? Always comes from the hypothesis. And then there'll be a square root in denominator, PQ, 0.6 times 0.4, divided by sample size here was 2,500, right? A big sample. Turns out the bigger the sample size is, the better our calculation. And I also want to use the parentheses around numerator, as usual. So let's put this in a calculator. Are you trying to use the calculator? 0.6 minus 0.62. Here you divide by a square root extracted from 0.6 times 0.4, right? And divide this by 2,500. So there we have the z-score, and I can see it's a -2 and a little something, 2.041 ... We don't need any more of those digits. So the z-score now brings us to the key part, to making a decision. Are we in H0 or in H1? And looks like we're someplace here, because 2.0 is not far enough to get into H1. And that's fine. We're in H0, so I say yes to H0 and automatically say no to H1. So I got the claim that is rejected. we just said no to the claim. So they tested this question about spending 750, actually less than 750, and they said that less than 62% of brides spend less than 750, and the answer is no, not less, maybe 62% or maybe more brides spend less than 750 on the wedding gown. So if you're producing wedding gowns, then you probably should know how many wedding gowns you want to produce, right? Because it looks like we get this based on this number. We need to know the level of production. So if you're producing wedding gowns, then you have so many of them at 750 price, and then so many, like 62% below 750. So you can make very useful inferences for your business, right? So we got this interesting ideas, and we're utilizing them to do various kinds of tests. Please notice that somebody could claim that the opposite statement. They could have claimed that not less than 62%, but more than 62%. Because technically, you could claim just about anything, and then statistics will check it out for you. So you can see there are various exercises here, and the setting is the same for all of them, but now we're going to use the formula for z-score that be slightly different with means and standard deviation use, right? So various exercises are here that relate to drug offenses, email users, telephone users, photocop legislation, and so forth. Cloning survey. Let's try 8. Cloning survey. Interesting exercise. So the poll considered over than 1,000 adults. In exercise number 8, we have actual number, which is 1,012, right? That had 9% that cloning should be allowed. So 9% wanted to clone people, and that was from the sample, so it's sample proportion. So we put that like hat above. So we also have this 5% significance level to test the claim. The key part is claim that less than 10% of people really support the idea of cloning. When say, oh, I don't support, I support. Well, again, for us, we don't want to do anything but use statistics in order to answer this question. Whether you believe this or not, you just go with the question of the exercise, and then you can do the discussion later. Also, I wanted to notice that p hat and q hat is used here in my denominator for that type of a calculation. So let me again try to go to the exercise and get this picture of our claim that will fall, looks like, into H1, right? Because H1 is when we're less than or on the left side, and that's my start, and H0 will be the other side, of course. So the level of significance is in this exercise given us 5%. 0.05 is for this little area. So the tables, as usual, are going to bring me with that number that corresponds to 0.05. It looks like last time we already encountered that area of 0.05. It is one of those favorites with the asterisk, right? The asterisk, because it's in between. That's like 500 in between 495 and 505. It's right in between, and since we don't know which one to take, we take in the middle, and that'd be ending with extra 5, negative 1.645, like that. So once the border is ready, now I need to get a Q for this matter, Q hat, which is 1 minus P, as usual, and that will be 1 minus 0.09, and this is going to be 0.91. That's my Q hat. So P and Q are here. I didn't write my H1. I got so excited. Technically, oh, H0. Technically, H0 is not really participating in the process, but just in case, I will write the opposite, right? 0.01 is greater. So for the z-score, now I need to utilize these 3 numbers, and those be P hat of 0.09, then P is 0.1, and then for denominator, I use 0.09 and multiply it by 0.91 and divide this by 1012. Please notice that we could technically have Q coming from that value of P, but we don't use it. We use sample proportion because that's what we have for sure. And what we have in a claim for population proportion, we're not using because we're testing if that's right or not. You see, what you can put your hands on is on your sample, and that's why we use P hat and a Q hat all the time. So it looks like, again, I will put this in the calculator, and if you compare what I'm gonna enter right now with the previous entry, you'll see it's really all the same pattern. So numerator is in the parentheses as usual, then divide, and then denominator with 0.09 times 0.91, and then put this over 1012, just like that. So there we go. Z-score is found. It is -1 and a little something, so it's -1.111 ... So we have the result of our calculations. So we test the claim and we hit H0, right? So we happen to hit H0 because it's not large negative number enough to be farther away than 1645 in H1 region. So we are in H0 region, and that's why I just supported the A0. So I say yes to it. And then I say no to H1. So I have rejected their claim. You see that? Rejected their claim. So what they claimed is that less than 10 people, 10% of people are supporting the idea of human cloning, and the answer is no, not less. It says, does it mean greater? Well, we tested claim. We did not make any inferences about the opposite side, even though logically you can say, yes, it's probably greater, but we just said no to the claim, and that's all we care about in here. So the procedure is lengthy and tedious, and that's all I wanted to discuss tonight, because that's really something that we, I guess, going to end with in this chapter 7. So there was a question, what's for the homework? Because we're going to have the exam a week after next, and next week we're going to do the review. And of course, I'm going to do more problems from chapter 7, but let me go back and see where we stopped with our midterm exam and started to deal with the final exam part. I believe we stopped at chapter 4. So for the homework, so far we have chapter 5 that deals with normal distributions. So we had first, let's see, 6 sections, right? There is never 5.1, there's never section 1 of any of these chapters. So we did 5.2 through 5. Actually, we skipped 5.4. So it's actually 5.2, 5.3. So I just have to list them. And also 5.5 and 5.6. So we had 4 sections in chapter 5. Then we moved to chapter 6, and we worked with the population mean and proportion. So that was 6.2 and 6.3. And then we had a chapter 7 that worked with 7.3 and 7.4 basically. Oh, and I totally forgot, we also had chapter 4. Yes, that's right. We also had chapter 4 because I stopped at chapter 3 for the midterm. So what we had here in chapter 4 was 4.3 and 4.4, right? 4.3 and 4.4. So these sections that we also been utilizing. So this is all we need for the final exam homework. As I said, on Monday next week, I will be going over this chapter 7 story a little bit more. I will also email you the practice final exercise like I did with a midterm. So it's all going to be in the same format, pretty much same type of exam. And our final will be, as I said, on Monday, which is going to be next, not next week, but a week after next. So I believe that's going to be May 1st, I think, or something. Let me double check the calendar real quick. Yes, we have a final, we have a midterm. It's actually in the syllabus. I even wrote. So let me put calendar 2023. And this is for the months of April, and then May. Yes, May 1st is Monday. So we going to have final on May 1st. And we have 2 more class meetings, Monday 24th and 26th April. That's when we're gonna do the review. And then Wednesday, very, very last day of class after final, if you would like to discuss your results or see how you can improve it, because I never mind if you want to do better, to give you some extra work to do to get better grade, why not? So on Monday, a week after next, we'll have our final. And the homework will be due for the final, so I just list it. And yes, ideally, you should email me your homework on the day of the final or prior to it, so you'll be prepared for the final, right? If you do before final, you're preparing for final. If you do homework after for final, so well, you're still doing it, I will still accept it, but it's better for you to do this before final. And yes, I will send it to you by email. So Monday, I will send it to you. I will send it to you earlier, so not at 5:30. So send it to me in afternoon time. So if you want to start early, then you can start early. So that'd be the plan. And what I can say that maybe I'm not going to give you a quiz today. I'll just wish you a good weekend. I think you deserve it. It's end of semester, right? You went through all of that already. And I'm glad that we're all still here. So I'm gonna just stop